Hello, everybody, and welcome back to Mr. Marlowe's 6th grade math class. Today, we are going to be working on lesson 24, multi-step problems using all operations. My target for the day is I can use my knowledge of simplifying expressions, order of operations, and properties of equality to calculate the solution of multi-step equations. My second target is I can check to determine if their solutions make the equation true. So we have an example, and the example is kind of long. It's a long word problem. So I recommend that you pause the video, read through this question, and then I'm going to read it out loud. And if any time you didn't understand what I said, again, you have the ability to pause the video, go back, and listen again to what I say. Okay, so I assume that you've taken a moment to pause the video and read through this question. Now let's read it together. The school librarian, Mr. Marker, knows the library has 1,400 books, but wants to reorganize how the books are displayed on the shelves. Mr. Marker needs to know how many fiction, nonfiction, and resource books are in the library. So we have 3 different types of books. He knows that the library has 4 times as many fiction books as resource books. And half as many nonfiction books as fiction books. If these are the only types of books in the library, how many of each type of book are in the library? So that might seem a little bit dense, but I promise if you walk through these steps, it'll all make sense. So question 1A says, what variable should we use throughout the problem? Now remember, the question is stating how many, I'm going to put a box around it, how many of each type of book are in the library. So we need to figure out how many of each type of book in the library. This is the main part of the question right here. So we're going to assign a variable that we're going to use throughout this problem, and we're going to come up with some different expressions to figure this out. So if we're going to assign these books a variable, we should probably choose a variable that represents the fewest amount of books, okay? And if we look back at the question, we know that the fewest amount of books is probably going to be resource books, okay? So we're going to use the variable r, okay? We're going to use the variable r throughout this problem because that variable represents the fewest amount of books. The resource books represent the fewest amount of books, okay? So you don't have to use r, by the way. You could use x, you could use y, but r will make it a little bit clearer. All right, so it says write the relationship between resource books and fiction books algebraically. Okay, so let's go back to the question. It wants to know the relationship between resource books and fiction books. And we're going to write an expression for that algebraically. So let's go back to the question. The library has 4 times as many fiction books as resource books. Okay, well, if we want to know the relationship, we're saying that R is the amount of resource books. I can start by writing R. Okay, and if there are 4 times as many fiction books as there are resource books, I can write the expression for R. Okay, and that would be the amount of fiction books. The amount of fiction books equals 4 times the amount of resource books. Okay. Question 1C says, represent the number of nonfiction books in the library algebraically. Okay, So if we're going to represent the number of nonfiction books in the library algebraically, right, we can say, well, let's go back to the question. There are half as many nonfiction books as there are fiction books. Okay, well, if the amount of fiction books is 4 times R, okay, 4 times the amount of resource books, how many is half of that? If we're looking for the number of nonfiction books, okay, what's half of 4 times R? Well, that would be 2 times R, right? So we could say the amount of nonfiction books is equal to 2R. I hope that makes sense. So we have, there are 4 times as many fiction books as there are resource books, and if there's half as many nonfiction books as there are fiction books, okay, then all I'm doing is I'm taking half of 4, and I'm multiplying it to the amount of resource books. So while there are half as many fiction books as there are nonfiction books, you could also say that there are 2 times as many nonfiction books as there are resource books. If you need to pause and go back and re-listen to what I said just then, I recommend that you do that. Okay. So now what we want to do is we want to write an equation that represents the scenario being how many fiction books, nonfiction books, and resource books there are in a library. Okay, so I'm going to switch back over here. We said that from the previous page, the amount of fiction books is equal to 4 times R. The amount of nonfiction books is equal to 2 times R. And the amount of resource books is equal to R. Going back to the previous page for a moment, we know the total amount of books in the library is 1,400. So my total number of books is equal to 1,400. So if we're going to write an equation that represents the books, what we need to do, right, is we need to add all of these books together. And we know what they should add up to. They should add up to 1,400. So I'm going to write our expression for the number of fiction books plus our expression for the number of nonfiction books plus our expression for the number of resource books. And I'm going to set that equal to the total number of books. If I add up all the books, they should add up to the total number, which is 1,400. I can simplify this equation right here by combining like terms. So 4R plus 2R is 6R. 6R plus another R is 7R. And on the right side of the equation, again, we just have the number of books. So, question 1E asks us to determine the value of R. Well, let's take a look. I have 7 times R equals 1,400. Now, as we talked about in previous videos, if I need to determine the value of R, I need to isolate R on one side of the equation, or in other words, I need to get R alone. Since R is being multiplied by 7, I need to perform the inverse operation of multiplication, okay? And the inverse operation of multiplication is division. Oops, sorry. So I'm going to divide both sides of this equation by 7. So if I divide this side of the equation by 7 and this side of the equation by 7, okay, over here, 7 divided by 7 is 1, so we say that just cancels out, all right, and we're left with just r. And 1,400 divided by 7, that is equal to 200. So the value of r is 200, okay? That's pretty easy, all right? But now we need to interpret, what does that 200 mean? Well, let's go back to our little key that I made up at the top of the page here, right? R is the number of resource books. So what does this 200 mean? It means there are 200 resource books in the library. How many fiction books are in the library? Okay, well, let's take a look. Our expression for the number of fiction books is equal to 4 times r. So if the question's asking the number of fiction books, I can copy down our expression for fiction books, which is 4r, or 4 times r. We know that r is equal to 200, so I can take this 200 and I can just plug it in for r. So my fiction, the number of fiction books I have, is equal to 4 times 200, and 4 times 200 is 800. Okay, so there are 800 fiction books in the library. How many non-fiction books are in the library? Well, we're going to do the same thing. We're going to look back to our expression for non-fiction books. Okay, so let's copy that down. The amount of non-fiction books is equal to 2 times r. Now I know that r is equal to 200, so now again, I'm just going to plug that 200 in for r. Okay, so I'm going to have nonfiction is equal to 2 times 200. Well, 2 times 200 is 400. So I know that there are 400 nonfiction books in the library. Okay, so we have resource books are equal to 200. Fiction books, there are 800. And nonfiction books, there are 400 nonfiction books. How can we check to make sure that we're right? Well, let's add these three together and see what we get. That's 0, 0, 2 plus 8 is 10, plus another 4 is 14, 1400. And that 1400, does that match the 1400 that was given in the initial problem? It sure does. So we can be pretty sure that we did this problem correctly. Okay, our closing and debrief. Remember, today was lesson number 24 on multi-step problems using all operations. Our targets were: I can use my knowledge of simplifying expressions, order of operations, and properties of equality to calculate the solution of multi-step equations, and I can check to determine if their solutions make the equation true. If you have any questions, please reach out. I see you guys every morning during crew. You can message me and remind, or you can send me a email at emarlow@rochesterdiscovery.com. Thank you very much. Have a great day.